I'm calling the uncertainties in the daily precipitation estimations, especially based on the observations from that we have. I divided this area into three main subjects. I'll give about the study area, then the part of the research that we've been doing, and so all the way to the conclusions from the work that we've done, that we may get some findings or some feedback so far. Now, the work that we decided to focus on the entire continent of Africa. If you go to the following slide, the next slide. We used the latest classification by the recent IPCC report looking to the 9 climate zones from the Sahara, Mediterranean, all the way to Madagascar, and looking also in the land cover, land change, and how they vary and how the climate influences this. But the most important part that motivated us to do this work is part of the changes that is taking place in the climate, which I recently read in a paper that was published in 2022 about the tipping points of the global warming. If we go to the next slide. Now, this work that was published by David Armstrong last year, part of the work that have been taking place, especially understanding the triggers of the climate tipping points. And we could see that exceeding 1.5 warming could trigger some changes, especially in the climate, whether it's in the iceberg, whether the precipitation changes, the temperature, among others. And so one of my interests is that because most of the models are predicting that we will likely surpass 1.5 warming if no mitigation is put in place. And in Sahara, we see that it's going to shift to the greening, and some parts of Africa will change here and there. And so there is much need for us to understand currently how the spatiotemporal variability in the precipitation is going to evolve based on the changes that will take place in the climate system. Would you go to the next slide? And so we try to ask ourselves that there is a need now for us to explore the knowledge of the spatiotemporal distribution of precipitation based on the available data sets that we have currently. And we see that there's a lot of innovations taking place, from the satellite retrievals to the merging techniques for the reanalysis products. And these products, for us, we cannot employ them to understand the distribution of precipitation in the areas that have got data challenges, especially for the continent, because they will require the validation process, which has always been a big challenge, especially over large areas of land. And so we picked up an approach that has been mainly applied, especially in the oceanography, which we are calling the extended triple collocation approach, to try to understand the weaknesses and the strengths of the available products that we have, especially over the diverse climate zones and land cover changes across Africa. So in this, if you go to the next slide, please. We defined our research questions, especially from the three main approach. There's work that was done earlier by Bex, which also did something similar, but it mainly focused on the soil moisture products and other available precipitations. But there is much more that has taken place from 2018 to 2019 when they carried that study. So we added more into the data sets and try to employ this new different approach in an area that has got no data sets. And so we decided to ask ourselves that from the available products that we have, the uncorrected and the corrected satellites, so their analysis, how do they perform diversely in almost all these zones? How do they estimate, especially if we just take some two indicators of the pod and far, the probability of distribution or the false approach, and how do they try to capture when we employ this approach that has not been practiced, especially in more into the precipitation products? How can they also give a good performance to use them to serve as a potential benchmark, especially for the precipitation analysis in the region? And with these three basic questions that we sought to answer, we designed our approach. If you go to the next slide, please. Just go next. Now, one thing we did is to pick all the available observational products, from the reanalysis products to the satellite observations to gauge-based products, based on the platform, the frequent rainfall observation on grades frogs, that was designed for mainly for the intercomparison approaches, and picked all these data sets from their native resolutions and horizontal, both native grid horizontal resolution to the temporal resolutions, and try to define from this graph here a common timeline when they all overlap, so that we could pick a study period that is suitable for all the products. So some products are having the temporal period from 1901 all the way to the latest. Currently, some are started from 1980s, but from all this graph, we identified from 2001 to 2016 as a time frame when we could consider as much products as possible. Then we go to the next slide. And so from this, we selected products that we categorized from the gauge-based, that is around 5 products, the analysis around 6 products, the satellite uncorrected that has not been incorporated in terms of the gauge observations to correct their performance, and also the corrected satellites from the TRIM observations to the Africa rain gauge to the CHIPS and all the way to the TAMSAT version 2, totaling to around 31 observational that we try to understand how they can perform across the region. And then now from this, we designed a methodology, what I'm calling a 3-tier approach. The first one was to see how they perform, especially at the daily estimates, employing the frequency of occurrence, employing the percentiles, the categorical, and which is the probability of detection and false alarm. And then we also try to look at the latitudinal distribution from the monthly and seasonal approach, and also at the annual approach, we try to use the spatial averages, temporal comparisons, and use some of the Taylor diagrams that we have to see. And then the second step, after using this, we go to what I'm calling descriptive statistics. If we can go to the next slide, please. From this, we also use the descriptive statistics also to try to test them, finding which approach or which data sets can capture this based on the correlation intermediation, the mean bias, and also the root mean square error, and trying to represent them, especially in a box plot estimates, picking the median and the quantiles that we have for maximum and the minimum of 25 and 75 percentile. And then the last approach that we employed, which we try to use, especially bringing into the precipitation or the climatology, because has been applied in other geophysical variables, but not into this area in many approaches, is the triple collocation approach, whereby the main assumptions that all these variables, they are not having any non-performance. We try to collocate through intercomparison of 3 independent variables. The one we pick, especially if it is reanalysis, we pick reanalysis. We know that the component of reanalysis is not related to the component of satellites. And in this area, we try to collocate them to find the root mean square error, how they are closely related in this, picking from this illustrative diagram that we placed in this figure here. Then go to the next slide, just explains more of the equation. The equation here that was developed by Masari, initially by Cox, then Masari 2014. We just coded this equation into the function and use it to employ for the triple collocation. And then now from this, we go to the next slide, which is some of the results that we have so far. So as I illustrated earlier, one of the main things that we needed or had in our mind is to address the 3 main questions. Number one is, how do uncorrected data sets perform over diverse regions? How do corrected perform? How do gauged perform? And how do this analysis also perform? From the very, very first fundamental question before we move to the next question there. And so if you move to the next slide, please, then in this, we just, as I mentioned earlier, we try to use the frequency of occurrence estimates, looking at the light precipitation, the moderate precipitation, and the heavy precipitation, picking also the spatial variances at the 90th percentile, and then using these approaches as listed here to understand their daily performance timescales. And so as we move to the next slide, please, now the first findings or the first analysis that we demonstrated here is to pick the 9 climate zones that we have over the region, the Mediterranean region, Sahara, West Africa, Central Africa, the Northeast Africa, all the way to Madagascar, and trying to estimate, especially in the light precipitation, which is the first one, the moderate precipitation, the heavy precipitation, defined within the threshold that we had highlighted in other slides. But overall, one of the things that we could notice is that most of these products that we have within the region are capturing, especially mainly the light precipitation. Most of them are able to capture this across the diverse zones. And the regions that experience much of heavy precipitation, we could see that, especially the Central Africa, the products also are able to estimate the moderate precipitations. But in this, we could see that most of them, especially the patient products, are one that are able to capture the heavy precipitations in most regions, but most products at this level, we could see that they are able to capture the heavy precipitation events within the region. Then we try to or try to understand their spatial performance, especially looking into the 90th percentile, which is about extreme events, how they represent that one. And in this slide, we try to also, yes, here we look at their distribution, especially for the 90th percentile, and mainly the thing that we try to understand when we categorize them from the satellite corrected, which is marked by the black one, the gauge-based, the blue ones highlighted by the blue ones, and then the reanalysis by red, and then the one for uncorrected satellites in this region. And one thing that we can just say overall that we could notice from the spatial distributions across the region that experience higher precipitations and then experience low precipitation, that most of the corrected satellites from our analysis and gauge-based are able to show higher extreme events, especially for the regions of Central Africa and also the Western Africa. But the differences in extremes, we can also notice that is a bit larger, especially over most parts of the region that we have. And interestingly, we could see that especially the gauge-based are having similar performance and satellite corrected, but others had varying performance from one region to another to help us in drawing a conclusion as we continue the analysis. Move the next slide, please. And so now, having that, we drew some few conclusions, and we move to the next understanding, especially now looking into the categorical statistics, whereby some of the indicators we're trying to use that if in any case we want to understand, especially for the drought monitoring or especially for the flood monitoring, how can we use these indices and look at the applicability and interpretations of them? And so we say that maybe when we see products that are showing the low false alarm ratio, where there's no overestimation, these products we know they can be applicable, especially for the drought estimation. The products showing the low or dry frequency bias, and the one that are showing the dry bias or no overestimation. But for the one that maybe are trying to, we try to see that which products, when we go to this understanding with high POD and also low wet frequency bias or low frequency bias that is preferred. This one we try to say that maybe if we look at them, we could say that they could be applicable for flood or extreme monitoring, and the other ones could be applicable for drought monitoring. And so from this understanding, we now try to plot the figures that we have, which go to the next slide. And from here, we also try to understand, especially from the pod perspective. And we because there is no reference data set that we could use at this level, and we did some preliminary analysis looking into the gauge-based data sets that have incorporated the observations from the in situ to build on them. And we take the REGEL from the CPC all the way to the GPCC FDD version 2020, we looked at the distribution, which is not captured in this slide here, the distribution of the stations across all these products. And one of the things that came out clear that the input, especially for the observations in the GPCC, especially over Africa, had more numbers compared to the CPC or REGEL. And so from that justification, we picked GPCC as a reference to be used for the sake of this analysis and try to run them to see how they detect the probability of detection for the GPCC as a point of reference in analysis. And one thing that we could notice from this, that the reanalysis showed a strong probability of detection compared to other products. The reanalysis is the one that marked in the red parts here. And we could see that especially for the ERA interim or the ERA 5 and also the MERA compared to all these other products, especially because REGEL being an observation had to have better performance. But IMEG, the products that by Funk, we could see that they also had some good performance for the correct data sets, while Patient as uncorrect data sets showed some good detection of 1 millimeter per precipitation per day. And so overall, we could say that the pod is most detected over the Central and West Africa region compared to other regions that we had in our analysis. Then now we go to the false alarm ratio, also looking into their distribution. And also, similar to the probability of detection, we could say that the detection of the false alarm ratio in these models are computed to test their scales for this one. And also, as expected for this analysis, because we use gauge of GPCC, we show that most of the products, especially for gauge here, showed some good scales compared to other products. But when you look at the reanalysis, we could also notice that the JRA has got some scales, especially within the Mediterranean region compared to other regions, but mainly overall, when we could notice from all that most of the satellites show some good scales, while we could also reanalysis across all, especially for the detection of false alarm ratio, never showed a good performance compared to the POD in the other analysis. And so from there, then we move to the next stage of now applying the descriptive statistics, which you can go to the next slide. Now, for descriptive statistics, we also try to lay some benchmark interpretations that will help us to guide us. That when we see some products that show low RMSE and low MAE, we could see that most of these could be applicable, especially for the crop modeling. And when we see some products that show some very high correlation to R2, that can also be applicable for this case. And so they can be good for the representation of the dry spell within the region. And now, based on these interpretations, we tried now to plot the figures, move the next plate based on the box plots. And from this, we rank them, especially for this is, I guess this one should be a correlation determination, because I'm seeing it's one here. My screen is not showing the down part. So from all this, also we rank them from the best performance all the way to the low performance. The best being with a high correlation determination 1, and the lowest being within the 0. And the distribution of the uncertainty within them, especially showing the outliers around them, is also captured within this box and whisker plots here. And within the about performance, we could see that for the R2, most of the products, especially start with the regional products, the CPC products, the African rain gauge products, and IMEG products, all the way when we rank them in order of the best performance to the least performance, we could capture them in this, which help us to make some analysis, showing a special boundary analysis and some satellite here having low performance, but some of the products within the gauge-based followed by satellite corrected in that order, showing a good performance in that case. Then the next slide was to test their RMSE, also being the lowest RMSE having the best, and the highest RMSE showing high amplitude. And so we could see the consistent performance, especially with the R2, whereby we see MERA, which is this the reanalysis, having a bit low performance, while the gauge-based products, especially the Regel, all, and CPC and R2, showing consistent performance, followed by chips in that order of better performance in terms of accuracy in the RMSE within the study domain. This is when to now do overall within the all African continent. Then now we also now compute, that was daily analysis. Now we go to the next tier level, trying to understand the estimations of these products, especially at the seasonal analysis, and then the last one is annual, and then we now employ them, the TC, to see the performance. Now from the seasonal analysis, we try to plot the distribution, especially looking into the range of the products here, especially per region, per seasons, per products. Now, within all this, we categorize the region, especially for the one for the March, April, May, then JJA marked by the blue color, the sun, and the DJF across regions, to see how do they capture these seasons that we have over the region. But we drew some few conclusions in this place, that most of these products are able to detect the precipitation distribution, especially as controlled by the ITCZ over the region, because when the Med region, they are able to have the climatology of the DJF, and also when look at the The South Africa, we can also see the distribution well captured across seasons from one product to another. But most of the analysis, especially over the Madagascar region, having much, especially of the DJF, precipitation anomaly. The distribution here of from 0 to 30, showing the models that are used in this study that we have here. But our main analysis for this one was based on the latitudinal distribution, which was of our interest, which is the next slide here. Now, from this one, this was the main part that we wanted to see the distribution latitudinally from one region to another. How do they agree from the higher latitudes all the way to the low latitudes for each seasons and for each part? But of main interest that we could establish, especially for the part for the September, October, November rainfall, there is larger uncertainty in the distributions of the models, capturing especially within the lower part from the 0 degrees going downwards to the central, that's around the central part of the Africa, showing large uncertainties, but of much interest where models of these products could show good agreement across the latitudes, across the seasons, especially is for the JJA, which they all represent so well. And within South African regions, we see that most of them, especially the reanalysis products, are having also large uncertainties in terms of latitudinal distributions across this area. And so we drew a few conclusions that over the Mediterranean regions, most of this show good agreements, but we see that large discrepancies is noted, especially in Southern African regions compared to other latitudes, with most of the products of the JRA, the Japan reanalysis 55 model, showing the large uncertainties compared to all other products that we have within the region. And so with these conclusions, we continue to explore our study in terms of ranking them from the best to the least as we move within the analysis. Now, the next stage is the annual performance, I believe so. In this case, now monthly, just annual cycle, then the temporal distributions, then the spatial averages, and then tailor diagram. Now, from this area also, when we move to the next slide, we just look into the patterns of annual capturing climatologies that we have, especially like the seasons, but now this annual, the regions of the months of low precipitations, especially the different regions like now Mediterranean, we see that the June, July, August showing all of them capturing the good patterns of distribution, especially except just for the Tamsat, which is not capturing the distribution well. But overall, in this analysis, we could not notice much, just especially the differences in the millimeters per month in some products being higher than the other. But most of them, generally, we can just say that they had some good performance in capturing the peaks, especially the regions when we know that, especially when we go to the East Africa, it is March to May. Then when you go to the other parts, especially for Madagascar, it's being May to November, which is the dry seasons, and all of them are able to capture that patterns that we have. So towards the end, as we end our analysis, go to the next slide, please. Again, here we based our argument on the reference for the GPCC just as a point of reference and to help us in analysis for this part here. Now, the justification as I'd used that most of them compared to because they incorporate the gauge-based, and GPCC had larger distribution in terms of the input of the gauge-based station, over 40,000 from the GTS datasets. And now when we look at the distributions also across different climatologies, we could notice that most of the analyses are showing some consistent low performance over the region. But I did a study early in 2019, and I could see that this precipitation CCSDR, the one that is uncorrected, the study that I did earlier showed especially not a good performance in terms of estimation of East Africa, and the same study could be seen. But over the ranking overall, the gauge-based that are closely like for the observation are showing better performance, followed by satellite corrected, which is giving an overall communication that correcting models before being used is an important step, having closer performance than satellite uncorrected, then lastly, the reanalysis because of the formation of them. And then now from all these conclusions, we move to the third tier analysis, which is the final step when we conducted in this, which is the triple collocation for optimal development maps. So now triple collocation here, our main desire was to find how these data sets are agreeing of a particular region so that we could assign that these products are mainly could be suitable for North Africa. These other products are mainly suitable for East Africa. These products are mainly be suitable for these regions, especially the ones that are having low collocations in terms of the RMSEs. Then in this, we could rank them that this region, this could be best, this region, this could be best. And overall, we drew this map that can be applicable to the climate users, for the dataset users, to see that within North African area, which that is having low RMSEs are the products captured by this part, which are showing this low, which is showing the higher, to be avoided for the use. And so we say that most of the models, or most of the data sets that we have, showed that low RMSE, especially the regions that are low rainfall, except for the TAMSAT and the CFS, but large RMSE is noted, especially for the Madagascar region and some of the parts of East Africa. But comparatively, overall, satellite reanalysis products continue to give a consistent least performance over the region, while satellites also continue to demonstrate some good analysis that we have in the region. And so we drew our key final conclusions as follows from the study that we conducted here. That uncertainties, especially for the daily precipitation, light precipitation is mostly prevalent over a region, but the detection for the non-precipitation days based on the categorical and the perfect suggests that it is ideally from whatever we look at the key analysis, there is no attainable irrespective of the products. But overall, within the region, within Africa, the IMEG products, which are uncorrected, and then this satellite captured here, which are corrected, and this GPCC could be applicable in many parts of Africa because of their consistent good analysis within the region. But JRA and TAMSAT might need to be checked in because across all the regions simultaneously, they having a challenge in estimating annual precipitation in all these regions that we had. And that is all that I had today. I'll be glad to receive feedback on how best we can improve this study. Thank you so much.
Thank you so much, Dr. Brian. Super insightful, and I just found the analysis and uncertainties in daily precipitations that you gave. Of course, among the many other things highlighted in your study, and I'm sure even before I give personal comments regarding your presentation, our congregation and participants of today are having sets of questions. So at this juncture, I'll welcome Alphonse Molo, who will take over the presentation at this point. Yeah, so.
Thank you very much, Brian, for that and great presentation. Though at times you started explaining some of the one from Japan, and I thought you were going to give us all the explanation. The less we admire the technical aspect that comes with this kind of a study, where you look at it that high level of satellite imagery and different aspects in terms of data correlation and how to get this right. So one of the struggles that occasionally as a continent is the whole idea about, and I want you to read one of these issues is, like with the satellite imagery and there is a paucity of data because of lack of some like the ground weather, just the ground weather, they are called what the ground truthing stations. locally. So that addresses the whole idea about geospatial. So will you speak to that in relation to now what is captured again via the gauge data, but now is a satellite adequate, or there must be some correction to get the data right? This will speak to the next thing that again, Africa, there's appreciation. This kind of a data having some sort of like a triangulation with the traditional weather forecast. So when we speak to this kind of a data, at times we also appreciate like the role of traditional kind of the indigenous prediction. Do you also find a time when like when you have this kind of scientific data, and take for instance the cyclone and some of the some stations that are really accurate, some of the pointers that are towards the study around Madagascar and Malawi, you know, that area was really cyclone. So do we have data that points towards it, but now borrowing local or the indigenous knowledge now that interface the two forms of sciences? But I also want to appreciate that you've brought in the land use, land cover, and just same, if you can corroborate that data and speak to the changes, you know, there's this whole campaign for intensifying land use changes within the continent. So can this really, this data speak to some of these land use changes and some of the findings that you've had in terms of or it's not really that specific, but straight now to some of the questions that have been asked by the audience. One of it is, how do you advance, how do you think, like Shuken asked this question on how do you think advancement in satellite technology, remote sensing technique can contribute to reducing uncertainty in daily precipitation estimate in Africa? And are there ongoing initiatives on projects that aim to challenges? And secondly, how do this uncertainty impact on the accuracy of data precipitation on daily precipitation data? Are there any specific region or time periods when uncertainty are more pronounced? So, so those are some of the questions that we'll really want you to speak into as we continue. So we'll encourage and the scholars to just either chat the question or just raise your hand up as our doctor is addressing this question. So karibu sana, Brian.
Thank you, Molo, and thank you so much for the good questions that have been raised. Now, to start with, one of the motivation or one of the main challenges, as you mentioned, that the gauge-based, the synoptic stations data sets are a great challenge over the Africa region, particularly for many, many compounding reasons we all know. And so this has hampered a good study to be done, especially in understanding or validating the products that we have. A lot of attempts have been made before, but some of these studies have either incorporated a small amount of data sets in terms of to use for validation and thereby giving not an adequate conclusion. Some have also done it within the small regions and within the scattered data set that we have. And so appreciating this challenge, especially for the paucity of ground-based observations to be used as a truth, we borrowed an approach that has mainly been applicable, especially in the soil moisture field, especially in the area of oceanography, because in those areas, there's a little approaches to get a good data sets or a good ground-based observations. So there is the concept of triple collocation, which we use, actually it has been improved to the extended triple collocation approach. This approach is trying to assume that there is no it can be employed to estimate or validate data sets in the areas where we don't have any ground-based as to be used as a benchmark. And so you take 3 independent and correlated data sets and then try to rerun them based on the functions to see if there's any correlation within each product based on this approach that has been stated in that area. And so the guy that developed the soil moisture products that is called Africa, it's called, there's a name, the broccoli work. He first used it to use, and so they were trying to use that. We could use a soil moisture, which has got different independent variables to estimate the rainfall and see how they can get the functions in them. So when he tested it and got that it can be used adequately, so we also borrowed the same approach to aid or to try to bring it in our field that can be used now by more other scientists in where there is no data sets. It is actually what we're trying to bring new. Could we borrow the ETC, extent triple calculation, to replace the gauge-based that we have as a problem? And when we tested it, we found that it could be applicable also following other earlier studies that have been done in soil moisture. So this one, we hope that if it is published, it will be able to address these gaps that we have experienced in terms of data validation due to lack of observations. Now, the data that we analyzed, we looked at it from the overall point of view, not looking into it, especially now going to the key basic important scientific questions, like the area being affected by the cyclonic activities, like Madagascar, like the area along Mozambique channels. Now, we believe that once we identify the data that are performing better in that climate zones as delineated by the recent IPCC, more studies could be initiated now from that point to try to check or use this product, so that is satellite that are estimated to show good performance. Could they be used now to track the cyclones or help in this area? So that one could be part of further studies for more other climatologists or people are interested in this field to use them. But most importantly, from the land cover and land use data set that we employed within that area, we had a bigger picture to look into more in-depth study, especially now even employing some NDVI products that can be used to estimate the land cover and see the distribution also. But at this moment, for these products might not be suitable for that, except if it is just maybe for the one like NDVI. So we might not say that this can be used for this. But how do you think the advancement of technology can contribute to this? If I paraphrase this question, because I never got it clearly, though it is important, if I may just read it 1 minute in the chat box here. I'll just take 1 minute to go through because I'm seeing so many messages here, but I want to get the last question. How do you think, okay, advancement, satellite technology, remote sensing, data simulation time can contribute to the additional uncertainty? Yes, the whole point here, satellite has been the best thing that ever happened to the 21st century since the distribution of them in the 1980s. And with this, they have been more, the aspect of correcting them, incorporating the few observations, improving their skills, I believe that they will be more suitable in terms of addressing the challenges that we face. And so one of the things that we can also say was that we asked ourselves, is there a difference between satellite corrected and uncorrected in terms of precipitation estimations? And yes, one of the things that came out clearly, that incorporating observations into the satellites before being released for the use could be a key factor in trying to reduce the uncertainties that we have in the daily precipitation estimation, which happens, especially going forward, will be more erratic and due to the climate change of 1 day precipitation or precipitation in 5 millimeters per day in terms of those extreme indices that we have. Thank you.
Thank you so much for tackling the question. So I we could get somebody who can interpret for us from our the Francophone countries, and a question from that. Yeah, so I see, Chidi, would you want to make a comment? Kofi, hi. And just apologies, we always have somebody who does the interpretation in French, and today, so I think somehow it's, we really apologize for other people who can help us with the work. And Brian, I think you would want to share this paper with us so that we can really interrogate further and even have another session. We now bring in some of the social scientists to speak into this issue of about climate information service, and now using now the practical implication. I know you are coming from the climatology side, but I would wish to have somebody who can topic both from your the perspective of the scientific and prediction, but also from the direction where we are where the rubber meets the road, the social scientists, and how they use this data. And one of the challenges that I'd want to highlight to you is some of this, when you speak to the local communities about, especially within the regions, they always ask this question, that when they're given this kind of a data, then informing some of their practice become a problem, because yes, the data, the real interpretation, like on maybe what gene you should go for, or what seed to plants, become a problem. So do you work with the social scientists, and as you some aspects of this kind of the predictions, and you work from that side, but you let the social scientists do the interpretation? And I would appreciate if you can really speak to give some of the closing thoughts on this topic. Thank you.
Thank you so much, Bwana Molo. Well, just to answer directly, if we work with the social scientists in terms of the applicability, I will say no at this moment, even though it's the next direction. Most of the work we are feeding into the, if I look from the framework of the IPCC, we are dealing with the working group 1, the physical science, trying to dissect exactly how the change is taking place and giving it in that scientific point of view. But looking into the mitigation, looking into the adaptability and applicability, going to the 2-3, we may have not emphasized on this. But if it is an approach that we are also trying to address nowadays in terms of our work, because even if you look at this, one of the key areas I was interested. Sorry? Someone is speaking?
I think maybe it's a microphone that was not.
Okay. Yeah. Yes. Now, one of the areas, like if you look at the way we're trying to look at it, how do we apply from the work here? Could we find the applicability in drought estimations, in flood estimation, in the area of agriculture applicability. So we also try to now incorporate these areas, but on a slow part of it. But mainly to give an answer, most of our part is more of physical science and little of applicability in terms of the where they're applicable in the social strata.
Thank you. So I think that makes a very good opportunity for some sort of between the social scientists and people humanity background to like collaborate in terms of this work together. And that's why we really want you to be really part of in terms of helping us with this kind of a data and this kind of really I'll call it a solid physics kind of a study on climate and climatology.
That will be fine, sir. I'll also be grateful to do that.
No, thank you.
Thank you.
Thank you so much. And of course, our speaker, Brian, for leading that session. I want to welcome Brian Otieno from the ARI network. Final comments, just checking around that I'm not locking in, and please come in.
Yeah, so thank you so much, Brian. And we would want to invite you. We have one of our specialists, issues of GIS, satellites, and other some of these topics. We are looking forward to a session where we can have you and him, so somebody who can do for us some interpretation, to just have a repeat of this particular presentation, but to have future engagement. That is Dr. Kipkemoy, I believe, so who will be coming in and break for us those good numbers you are giving, and also to really link it in a language that the sorry for our French speaking brothers. Today the interpreter Dr. Joe was engaged, but I think he learned that we can continue this kind of a conversation. So for ARIN, our executive director, Dr. Ioane Satella, he's in South Africa for just to discuss some of these issues on climate change and development. It's called the Resilience Partnership, I believe. So they've been there for a week long, and he would want to be really part of this meeting, but he's things, and he's just said climatology and issues about predictions. So thank you. And I also want to say thank you so much to our guest speaker, Dr. Brian Ayugi, who is in, I know right now he's in South Korea. So we want to appreciate him so much for taking his time late into the night to be able to be part of this conference. So I'll hand over to So the conversations continue, and let us. I'm sure he'll share with us the paper that is presented today. But I want to hand over to our fellow who convened this meeting, and we also appreciate you so much, Juliet, for this great session. So thank you, and I hand over to you.
Thank you so much, Molo. Could someone confirm that you can hear us? Awesome. All right, so that brings us to the end of this session, and I believe that was impactful to all of us who attended. I personally was kind of venturing into something totally new, but I'm really grateful that the ARIN platform gives us this opportunity to actually learn and get a glimpse and bits of different topics around climate change. So if you made it to the end of this session, big congratulations to yourself, and we look forward to seeing you again next Friday. As our norm, we now want to take a virtual selfie, and our media team is on standby. So I'll give us 30 seconds to turn on our cameras if we can. And also please, our deepest apologies. We've gone 6 minutes past the hour, but it was for a good cause. So welcome us to turn on our cameras. So I see people are still trying to find their way. So I'll give us 3 more seconds as I check with our media team. All right, so I guess you're all ready, and really nice to see you and attach all of your faces to the voices that we heard this evening. So at the count of 3, I'm gonna welcome us to put on our best Friday smiles, even as we dive into the weekend. So 1, 2, and 3. Brian, are we good? All right, thank you so much. I'm really grateful that you made it. And now on behalf of the Africa Research and Impact Network and all our stakeholders and partners, I would like to take this chance to thank you for making time for this review. And I wish you a restful weekend ahead. Please take time to rest. Thank you.
Très bien.
Thank you so much. Bye-bye.
Thank you. Bye. You're free to leave at your own pleasure.
Thank you.
Hello. Can anyone hear me? Mr. Molo Alphonse, did you say something? I think my network may be crazy. I see you opening your mouth, but I don't get a thing from what you are saying. At the level of the ARIN office, can anybody hear me? I wanted to reach Madame Juliet. Is she still available? It's quite unfortunate.
Hi, Alvin.
Okay. Yes. Okay. Great. I think I can.
Alvin.
Yes, I can hear now. I had something to follow up with Madame Juliet. I don't know if she is still on the call, and I know you just rounded up and you're still quite busy at the level of the office. All right, so we were supposed to, at the level of focal points, we were supposed to, if my agenda is not failing me, we were supposed to have some kind of a training in within this week in June. So I didn't hear any other updates about that. So I just don't know if we should expect. It was supposed to be online. I don't know if we should expect or it has been pushed forward. I don't know if anyone on this call can clarify me.
I'm going to call you right. I will call you in a few.
Okay, all right, that works.
Let me call you.
All right.